So for number 11, we're going to give a useful denial for each statement. So for A, we have the statement x is a positive integer. Now let's just put A in propositional form. So for A is just P, where P is the proposition x is a positive integer. So here the denial would just be not P, so x is not a positive integer. That would just be our denial. Very simple. So for this one, we'll write this down. X is not a positive integer. So that is the useful denial for item A. So let's look at item B. We're going to set up this in propositional form. So for B, we have that Cleveland will win the first game or the second game. So we have P, where P is equal to Cleveland. So Cleveland will win first game. And then we have Q, where this is Q is equal to Cleveland will win second game. When I put these marks, I'm just saying I'm repeating that sentence. So my propositional form is P or Q, right? Which means Cleveland will win the first game or Cleveland will win the second game. So when I deny this, I have the denial of P or Q. And now we just have to remember De Morgan's laws, right? Please don't think that this is equal to not P or not Q. That is not the case. So using De Morgan's law, this is equal to not P and not Q. So not P means Cleveland will not win the first game and not Q. So Cleveland will not win the second game. So let us write this down. This is Cleveland will not win the first and not win the second game. So that is our denial for this one. Very important to remember De Morgan's laws. Okay, now let's do item C, right? So for item C, we have that 5 is greater than or equal to 3. Now it's important to actually remember that this is also, we have two propositions here. So we have that P is equal to, P is the proposition, 5 is greater than 3, and Q is the proposition, 5 is equal to 3. So what we're saying here is P is greater than or equal to 3. So really our propositional form is P or Q. So when we're denying this, we're saying, okay, not P or Q. And once more, with De Morgan's laws, we're saying, so not P and not Q. So we're saying, okay, 5 is not greater than 3, and 5 is not equal to 3. So if 5 is not greater and 5 is not equal, the only thing that's left for us is to say, okay, 5 is less than 3. That's the only other way that it could be, right? So we say that the denial here is 5 is less than 3. Okay, so this was C, right? Let's look at item D. So we have the 641,371 is a composite integer. So for item D, we just have that P is equal to, is the proposition 641,371 is a composite. is a composite integer. So now, because our propositional form is just P, the denial is just not P. So we say that it is not a composite integer. So the other way to say it is that it is prime. Either of those work. We'll just say that 641,371 is a prime integer. We could also say that it's not composite would mean the same thing. Okay, now let's look at item E. So for all of these, we're just going to set up the propositional forms and then deny it and then put it back into words. So roses are red and violets are blue. So we have here for E, we have P is roses are red. Q, violets are blue. And then what we have here, we have P and Q. This is our propositional form, right? They're red and violets are blue. So when we deny this, we're going to say, okay, not P and Q. And once more, please don't think that this means not P and not Q. That is not the case. So we just have to apply De Morgan's laws here. So this means that this is equal to, this is equivalent to not P or not Q by De Morgan's laws. So if this confuses you, please put the truth tables, right? Compare these two statements and see that they are equivalent. So we can say that the denial is not P or not Q. So roses are not red, or violets are not blue. Violets are not blue. Okay, now let's do F. So we're saying that F, T is not bounded or T is compact. So for F, we're saying, okay, we have two propositions here where P means T is not bounded, and Q, T is compact. T is compact. So our propositional form is P or Q, right? It's not bounded or it is compact. So P or Q. So when we're denying this, we're saying, okay, not P or Q. And once more, by De Morgan's laws, we have that this is equivalent to not P and not Q. Very important to remember De Morgan's law. So we're saying, okay, not T is not bounded, right? So then the denial of not P is just T is bounded, because it's a not. So we say that T is bounded. And then we have and not Q. T is not compact. And T is not compact. Yeah. Let's see. Now we have for G, right? M is odd and 1-to-1. So once more, we have two propositions here. We have for G, yeah. So for G, we have P is M is odd, and then we have Q, M is 1-to-1. So our propositional form is P and Q, right? It is odd and it is 1-to-1. So the denial is not P and Q, and by De Morgan's laws, this is equivalent to not P or not Q. So when we write this in words, we're saying, okay, not M is not odd. So if it is not odd, it is even, right? You could either say not to odd or even. I'll just say that it's even because it's easier to write. So we're going to say M is even, M is even, or not Q, or M is not 1-to-1, or M is not 1-to-1. Now let's do the second part of this problem. So let's just scroll up. So for item H, we do have, let's see, the function has a positive first and second derivative at x naught. So we say that for H, P is the function, we say that f has a positive first derivative, and Q, P is equal to f has positive second derivative. And I should say at x naught, at x naught. Okay, so now the propositional form is of P and Q, right? So our denial would be not P and Q, and by De Morgan's law, so this is equal to, or rather equivalent to, not P or not Q, right? The denial is not P and not Q, but rather not P or not Q by De Morgan's laws. So we can say that not P, so if P is f has a positive first derivative at x, x0, we're going to say, let's see, has a positive, so we're going to say f does not have a positive derivative, at x0, or oops, that's not what I meant to do. So let's see, f did not have a positive, I should have said first derivative. So does not have a positive first derivative. And then I'm going to scroll this over at x naught, and then we can say or not Q, right? Or f doesn't have positive second derivative at x naught. Yeah, let me just zoom that out, right? So I would be careful in assuming that we're saying that f does not have a positive first derivative, that the opposite, it's saying that f has a negative first derivative, just because there's some kind of tricky implications here that we do have to take care of, right? Because so let's see, let's do item I. Because it could be that the first derivative doesn't exist at all, right? So the denial should say does not have, instead of saying that it has a negative one. So we're doing now item I. So for I, we do have two propositions here, right? P is the proposition G has relative max at x equals 2, at x equals 2. Actually, we do have three propositions here, so I'm going to go Q is G has relative max at x is equal to 4. And then we have R, let's see, G has relative minimum at x is equal to 3. Okay, so what's our propositional form? Well, we have P or Q and R. So our propositional form is P or Q and R. So now let's think about how we are going to deny this. So the denial of this is we're going to put a not here, right? So once more, we're going to look at De Morgan's laws. So this means not P or Q or not R by De Morgan's laws. So we just looked at the outer structure, like, right? Assuming that this is kind of one thing. So let's call this A. So this would be not A or not R. So now we have to apply the not again into this P or Q. So when we apply it, this goes not P and not Q or not R. So once more, we're just applying De Morgan's laws twice. So this is our denial over here. So let's write this down. This is not P, so G does not have relative max at x equals 2. So let's see. G does not have relative max at x is equal to 2 and not Q. G does not have relative max at x equals 4 and x equals 4. Or, then we can say, or not R, or G does not have relative minimum at x equals 3, or G does not have relative min at x is equal to 3. So we saw that this is a compound statement, so we do have to apply De Morgan's laws twice. Let's see. Now we're missing item J and item K. So for item J, we have neither z is less than s nor z is greater than or equal to t is true. So let's put our propositional form. So we first have P. P is z is less than s. And Q is, now Q is z is less than or equal to t, right? So our propositional form is neither one nor the other. So our propositional form is not P and not Q. Now this is kind of tricky to read it, right? But it is and not Q. That's what nor means. Neither nor, right? If we had read it either z is less than s or z is less than or equal to t is true, then that would be a different scenario. So this is our propositional form, not P and not Q. So now let's deny it. So not P and not Q. So we're just applying De Morgan's laws, right? So we're saying, okay, not P or not Q. Just applying De Morgan's laws. where we apply the not to each one, and then the and becomes an or. So when we apply it, not P just means P, right? So we can just say that for this one, Z is less than S, or not Q, and then we can say or Z is equal to or smaller than T, or Z is equal to or smaller than T. And lastly, for K, we have that R is transitive but not reflexive. So we have the propositions P, R is transitive, and then we have Q, R is reflexive. And let's set up our propositional form. So this is R is transitive but not reflexive. So the way that we should interpret it is but not means and it is not, right? So just be very careful with the wording. It's transitive and it is not reflexive. This is what but not means. So we're going to say the propositional form is P and not Q, right? So when we deny it, we're saying, okay, not P and not Q. So by De Morgan's laws, this is not P or not Q. In other words, we're going to say not P or not and not cancel, so not P or Q. So R is not transitive, right? So we can say that R is not transitive, or R is reflexive. Let's see. Yeah, so not P or Q. And that is it for our denials. So I'm just going to zoom it out so you guys can kind of get the full picture of it. Let's see. Yeah. So once more, it's just the two parts that you have to be careful of is applying De Morgan's laws when you're denying, and then sometimes you're going to have to apply De Morgan's laws twice if you have compound statements, as was the case, let's see, as was the case with these last ones that we had to kind of sometimes apply twice.